So it's getting recorded, right? Okay. So let's start. So our first question is, we have to implement two lowercase function that has a string parameter, and it would return the same string in the lowercase. Yeah, it's a straightforward. So any approach for this? Like, how do you proceed? Anyone? Am I audible, right?
Yes, yes.
Okay. Yes, so we have to convert it to lowercase.
If so, just a curious question. Then it would be there would be some kind of a string which is non-empty, or there is like some space in front or back end.
Yeah, that could be. Yeah, that could be, sure.
Which needs to be stripped out.
Exactly, yeah. So what I did is like straightforward, just checking whether it is alpha character or not. I mean, English letters or not, lower or uppercase. And if it is less than 97, that means it was earlier what do you say, capital. So we are converting it to small. Or if it is originally small, only just append it and just keep on, what do you say, keep on the return the final string.
Okay, so you just change only when it is caps,
Yeah.
uppercase. Okay.
So why plus 32?
To lowercase.
Okay, so for example, whatever the number is there, need to add that number and it will automatically be making
Convert to lower. Yeah.
okay ASCII character of that.
ASCII. Yeah. Yeah. So any other approach apart from this? I think anything.
I think that is the only way you could do it, right?
Exactly. Yeah. I mean, straightforward. Like if it is capital, just convert to small. If it is small, keep as it is.
Right, right. But have they mentioned any other approach in the solution?
Solution? No, I think this was only like most of the places I saw. I think.
They are using a hash map in one case. So what they are doing is, they are having a map of mapping of uppercase to lowercase, explicit.
Okay.
Yeah, and then they are actually looking into it. If it is instead of the way you are using it,
Yeah.
they are actually having a map. That's
For example, the key would be the capital or
right. The key will be the caps. Yeah, uppercase.
And value will be the ASCII code.
No, value will be the lowercase. No ASCII code. Yeah.
For example, this key would be H uppercase, and that value would be the lowercase h.
Right.
They are specifically assigning these because that would be because it's A to Z is 26 characters, and then they will be at most 26 alphabets.
Right.
But extra space they are taking, right? Here I'm not taking.
Yeah, they are taking extra space.
So that's a constant space. That also true.
But that also possible if someone doesn't know these ASCII characters numbers.
Right. Yeah, that's very important.
Yeah, because like I was also not knowing this number, so.
Yeah. Also, the way he did adding 32, you won't come to know that, right, in an interview. What is the difference? Yeah.
Yes.
Right.
We can ask them, right? They'll tell us, or
I don't know.
That up to the interviewer. If the answer is this only, then they'll be like, "Why should we tell?"
Yeah.
Now, in worst case,
Yeah, but
nothing
at
is.
least first we have to, present our approach without asking him. So this will be a good approach, right? And then we can say, okay, I know this, but then can you give him, I don't know what are the differences. If he can help you, that's good.
Yeah,
And if you don't have any approach, then he will be reluctant to help you, it seems like, yeah, right? You
exactly.
never know. Yeah. Yeah, so this is
One
good.
one
So
more
let's.
thing is, if you assume that, if you assume that the string doesn't contain any tabs or some special character like things, you can blindly add the 32.
No, it can
I mean,
contain. That's why is alpha is there.
no. Actually, the only special characters like slash tab or new line, something like that.
Underscore. Yeah.
Yeah. So if you see the task key table, so all the characters that are less than 32 are actually escape sequences kind of thing.
Okay.
So if I can, I mean, you can blindly set that. I mean, if you know that it doesn't contain any tabs or new lines, I mean, those are the only special characters kind of thing. You can blindly set that fifth bit. I mean, that 32 you're trying
That's
to add, right?
yeah,
Yeah,
yeah, yeah.
if you set that 32 fifth bit, you will be able to, I mean, convert that low to higher.
Lowercase.
Yeah, sorry, lower to
Yeah.
lowercase.
So in that case, I'll not check ORD of I less than 97.
Yeah, you
Here
don't
I'm
need to
checking
check
because
any.
there could be that special characters.
Yeah,
So you're saying that we should OR it, right? That 32 bit, the bit
yeah,
which, okay,
yeah,
just OR it, okay.
yeah. Even I checked the test cases, so that doesn't contain anything. So
Oh, okay.
Oh,
you just need, if you set that bit, I mean, without any checking, that should be enough. I mean, that will ideally
work
pass.
fine. Oh,
Yeah.
Hmm, good. Yeah.
yeah, that's a good one. He's narrowing down the what do you say, like the cases. But
Hmm.
the generic would be like it would contain, right? In general.
Yeah,
Yeah,
should be.
yeah. Okay. Okay, then let's switch to next.
Yeah.
So we have to construct a binary tree from pre-order in order, and duplicate won't exist in our tree. So if you take pre-order, I mean this would be the root. So if this is the root, then its left child will be 9 and right child will be entire 527. Then again pick 9. So there is nothing over there for 9. It's like, so this is 3. 3 would be our root. Yeah, here it is. And 9 would fall into the left bucket and these things would fall in our right bucket. And simply 9 is there. So simply we'll append 9 over here. And for 20, 15 and 70, so I'll pick 20. If I pick 20, then 15 will fall to the left and 7 will fall to the right. After that, 15 and 17, if we check, they are single elements. So further, we don't need to divide this. So this is, yeah, so how to like proceed here?
So we have given inputs like the pre-order, in order, and then you have to
Yeah.
construct the complete tree,
Yeah.
Okay. So there won't be any constraints, nothing to worry about because it's more
Duplicate
of
won't be.
if you have a duplicate numbers.
Yeah, but here they are telling we won't.
Okay, we can come to that later after we are done with solving this, but that's a good one. We should
Yeah.
discuss that also.
No. I mean, if there are duplicates, you will not be able to find a consistent solution, right?
There
I
will
mean,
be
there
not
can
a
be
unique tree.
yeah, there cannot. I mean, yeah, you might have to search for multiple times.
Exactly. Yeah.
Really?
And even
Okay.
and even if pre-order and post-order is given, you won't be able to draw a unique one. I mean, a tree. You have to, in order should be there.
Okay. Let's focus on this one first.
Yeah, yeah,
But
exactly.
pre-order, post-order, we should be able to do, right? If we have those.
No, I think in order, I have read somewhere that in order must be there for, I mean, you can draw multiple trees will be there, but unique tree you can't get out of post order and pre order.
Yeah. In order has to be there. Yeah.
Yeah.
Okay, so in this case, so what we would do, as you said, first to pick up the pre-order, okay, the first one, which will always be the root, correct, and then you actually find that in that in-order set, and then you divide the tree. So
Yeah.
you'll be able to divide that, right? It's like a what the way we do divide and conquer.
Hmm.
So take that as a pivot, and then make a left and right subtree of it, and then keep on recursively doing it, something like that.
Till you hit the one, I mean, single
Yeah,
element.
yeah, till you don't hit the last one, and then actually you create a node for that and then return. So, but the only thing is, how do we find the particular value in an in order? Because
Yes.
either you'll have to go through the whole array every time, or maybe do something different.
You'll have to go through array or some function will be there for calculating the index of it. Like if I get 3 from pre-order, I'll check at which index it is lying in the in order. And depending on that index, I'll divide into left and right. But again,
Yes. Uh-huh.
index again will take, I mean, internally it might be going through a linear search, right? Something it will go, that function.
Well, indexing means what type of indexing you're talking about?
Like 3 is there. So in order, I'll find at which index 3 is lying. So 3 is at 1, right?
Okay, so if you go through linear, like
So that,
sequentially, right?
so
Yeah.
we need to where it is situated in order. So if three, first of all, three is there. So then we need to check the left and the right. So at the left side, we will be knowing that left side would be the 9 and the right side would be all the 15, 27. So again, we need to go at above and check that. So for example, here, so I think 20 is there. Sorry, yeah, 20 is there, and 20's right side is 7 and left side is 15. So something like this we need to check, like what would be for the right and left. This in order would help what would be the right and left, and to choose a node, I think pre-order would be the point.
Yeah,
Something.
yeah. For choosing node, you'll have to take pre-order because that will give you the root. I mean,
Yes.
yeah.
Yeah, but from pre-order, we are just going to get the root, right?
Yeah.
Okay, we just take that root, and that is the node, because that is one which we can actually establish on, and then we can actually develop the other part of the trees, right?
Yeah. Yeah.
Okay, makes sense. Yeah, so that is straightforward, right?
Yes, I
I know
think.
it's not so easy though, but
Yeah.
actually, just to discuss, it's very easy. But while implementing, you will have to take a lot of care. Yeah, that is for
Yeah.
sure. Yeah. So, how would you do for that indexing? Either you iterate, but that doesn't make sense, right? You go through the
So
whole
there is
array.
a API called dot index that will give you the index, but internally it might be running through a linear search, I think.
Oh, that's a Java API. Okay. Mhm.
Yeah, in Python, or Java also they might.
Okay. So in
Yeah.
our case, I'll use something like a map. I will do a map.
Okay.
I'll map for C++. Actually, I'll do a map. Sorry, for only for C++, and then I'll put the key as the values of all these in order,
Hmm.
and then I'll keep an index for each and every key value pair. Okay, so the value will be my index. So I'll go through
Hmm.
the scene order array initially, and then I'll use the keys of whatever the values are inside that in order, and then map it to their indexes.
It's the
So
same
when
thing, I think. So here also you're doing a linear search first throughout the array and then plotting the map, right?
so initially I'll have to do it, yeah.
Yeah. So I think index method will also do the same thing. For internally, it will do the same thing. What you are externally, I mean, explicitly doing. The implicit same function might be going in the index also.
Yeah, maybe, yeah.
Yeah.
But that is what it will have to collect some information. But when he's trying to access it at that time, it's going to be just O of one, right?
Yeah. Yeah. Exactly.
And so then you have a map, and then you actually run some other recursive function and do all this stuff. So when you have established a map of that in order, uh, but then you'll have to uh, monitor the root which is in the pre-order, correct?
Yeah.
So every time you'll have to keep on incrementing that. But I really didn't understand, because if we go a recursive way, how are we going to maintain that, that index of a pre-order?
We
That I
will
really was not sure. Hmm.
we will knock out every time the root we use it.
I just remove it from the array.
Yeah. Because we don't need it further, right?
Okay, that is a good option. But the thing is, we should not modify that input, and all those things might come in. Okay, but yeah,
It's
to start with, we have
it's not.
something to do. Yeah.
They haven't
Mm.
mentioned like right. We can't.
Yeah, that's fine. But when actually you are in an interview, the interviewer will immediately turn everything
Oh.
around upside down and say, no, you can't do it. So we'll have to be ready. But to start with, that is a good option, I would say, to
So
just keep
what
on
would be like?
popping.
I mean, if we don't go through that way, what would be the other option?
I don't know. Actually, I had very difficulty doing that. So I was stuck there. So maybe I think you guys
Yeah. So
have some input support it. Yeah, that would be great.
somebody has something to share.
I
Or
think
go ahead.
I think the recursive function can just take that as a parameter, right? So, for example, we'll have some parameters in the recursive function. To start with, we'll have the starting index of preorder, which will start from 0. Then let us take the bounds of the inorder, which we are going to handle. So in this case, it will be inorder, 0 to whatever the index of 7 is in the inorder. Then, so that is a recursive call. So basically we take 3, we know that it is going to be a root. Let us create a node for it. And we know that its left will be created from the tree, which happens to be basically just 9 in the inner tree. And on the right, the subtree will be coming from 15, 27. So that range. So there are also 2 recursive calls. So those sub-recursive calls will take pre-order index as 1, because that is what the progression is, and the inner indices as for the left side it will be, I would say, 0 to 1. Basically my convention is the right is not included. If I'm doing that, then basically 9, so 0 to 1 in the inner is the left subtree, and then 15, 27, which is 0, 1, 2, 2, 3, 4, 5. So 2 to 5, those 2 indices for the right subtree. And anytime we are going down, we are basically incrementing the pointer in the preorder array, because there is no need for us to go back in the preorder index. We know that whatever we see, that is going to the first index, that is going to be a root anyway.
But if you are doing a pre-order, and then you will have to go to the left subtree and the right subtree. So if you increment for both of them, so are you not going to move 2 times ahead?
No, I only consumed one node from the preorder. So so basically, because I consumed only one from the preorder, So only I'll be incrementing always by 1. And the rest, whoever is using, for example, for the left subtree, I'll be passing 1 as my index for preorder, which is 9. And that matches with the range I am passing here for the inorder range, which is 0 to 1. Correct?
Mm-hmm.
Okay.
And so for the right, you'll go for the second.
Yeah. So
okay, makes sense. Yeah. I never tried that. Okay. Yeah, I think so. It should work.
Yeah, it should. So Rajendra, you want to share the code? Like,
unfortunately, I don't have code.
okay. Okay.
Yeah, but it should work, right? Yeah.
Definitely.
Because yeah, if you look at this way, 3 will be 0. If you go for left, it will be 9. So that is the left subtree.
Okay.
And then if we increment to 2, which is 20, 20 is the right subtree. Correct. Yeah, it is right subtree. And then
Yeah.
again in that, if you go for 15, which will be the left subtree again in that one, in this
Yeah,
level 3. Yeah.
Yeah, mind you, that is a recursive call. So
Right,
whatever
right.
you get, you just do +1 for left, +2 for right.
Right. Yeah.
Hmm.
Yeah. One problem with this approach is if the tree is completely right skewed, then if you go to left, you won't get anything every time.
Sorry, what?
Uh, if the tree is completely right skewed, I mean, like if order and inorder both are same, exactly same, like 3 9 20 3 9 20 like that. Then how would you handle that?
Okay, very good question. So in that case, you will see that in the left subtree, you don't see the root at all. So at least the root should be there in the left subtree, left range, correct?
Yeah, initially when you're starting a tree, you won't find anything at the left side. But when you move on to onto the next element, like for example, if you take this first example, like 3 9 20 15 7, when you're in position 20, when you what you'll do, you have the same index in another 20. So you take the left part as its left subtree, where you have 3 and 9, but which are the root elements, not the left elements.
Sorry, I missed you. So if you are talking about pre-order being 20, 15, 7, then the corresponding in orders must be 15, 20, and 7, correct?
Yeah. In this case, it's okay, but what I'm telling is, if you see, actually I tried this approach, and one case I'm failing is there was a case called 1 2 and 1 2. Pre-order is 1 2 and in order is 1 2. So that's like right skewed. It has only right elements. For example, if we take 1 2 3 4 as elements of the pre-order and 1 2 3 4 as the in order, that means it is completely right skewed.
Correct, correct. So in that case, we can get that trigger from the bounds. So for example, what is the parameters that my parent call got, and if I got anything on the left subtree or not. If my left subtree length is 0, that means there is no left subtree. In that case, I will just pass it everything to the right subtree. I'll just do a +1 and call the right subtree. That is the extra check we'll have to do. Are you following me?
Yeah,
But
I mean,
that is linear, right?
Sorry,
But that is linear, right?
what is linear?
I mean, you need to check every,
Yeah.
linear in the length, right?
So every time we are finding the root in the inorder, that is going to be the linear. So first time it will be order of n. In the next time, if you see next level, collectively everything will be order of n. So there will be n log n, the search, total search will be n log n, because there are log n labels, and at every level collectively we are doing the order of n search, and it will be linear, of course, because there is no way we can establish use anything else. It is not sorted, nothing.
Anyway, we have to visit each and every node, right?
No, no, as he's saying already, that search would, if it is a skewed tree, it would lead to n square.
Yeah, skew tree, it will be.
But okay, before even coming to that time complexity, so the way what Dilip was saying, that test case where it is skewed, can we do it, Rajendra?
Yeah.
Over your approach.
Let us.
Can we take an example if very quickly and
Yeah. Whoever.
Yeah, Dilip, can you give that example what you are talking about?
Yeah. So yeah. You can take same pre-order, whatever the pre-order is, as in order also. Like they both have the same elements in same order.
Okay. Same. This as the. Okay.
Okay.
So if we take that, so what was the function we had? The function basically took. So let us say it is. Oh my God, it is pretty bad. How do I write? Okay, function. We basically shared. No, it's not working. How can I share this?
Maybe we just go through the steps,
Okay,
you understood that, right? Your approach,
okay.
it's okay.
Sure. So, no, it is very important that I should know what I'm passing, right? So, if I, so to the parent, this is the pre-order's root index of the pre-order root. So that is 0. Then I'm saying I'm going to pass the bounds of the inorder. So that will be 0 and a length. So length I'm passing 1, 2, 3, 4, 5, and my max bound is not included. So this is what I got, the very first one. So when I see 3, I'm searching for 3 in the inorder. So I found that, okay, anyway, I'll find 3. I create the root. Then I find its left subtree. I see that there is, so the 3 is found at 0 again. If 3 is found at 0, so look at this. I don't have any range left for the left. That triggers that there is no left. I started with 0 and I'm finding this 0. Okay, so that means 0 to 0, there is no, because this 0 will be always the outbound, which is not included. That means there is nothing left on the left subtree. So that triggers me. That is the signal that there is no left subtree. So all I do is I basically, in the next one, I pass 1, because I pass 1. Then I say, what is my right? My right is, it is 1, 2, 5 again. Like that it will go. So similarly, so 0, 0, 5, 1, 1, 5, I guess it will be 2, 2, 5, 3, 3, 5, 4, 4, 5, 5, 5, 5.
Okay, got your point, yeah.
And there will be no left. Okay.
Yeah, that's good. So Dilip, does this seem okay?
Yeah. So I just want to point out we need to handle that range so that we can, that works now.
Actually, what you brought up, Dilip, that is a very interesting point. It can happen on right side also.
Yeah. It can.
It can happen on right side also, but that is only check. That's all. I mean, for both left and right, we'll have to do those 2 checks to see if really that exists or not.
Yeah. Yeah. Sorry, Uday. Actually, so yeah, your time complexity in this will still be n square, right?
Actually, it is still our n log n, but here the log n level. So basically, we said it is n times the levels because the level here is n, so it is n square.
N square. Yeah. So that is okay in this case, right? Because anyway, if it is a skew tree, it is always going to be that time complexity, correct? Whatever the way you do it. Is
In
it not,
fact,
Uday?
how about this? If it is a skewed tree,
Mhm.
either the in-order will be increasing or decreasing sorted, correct?
Yeah, worst case.
I mean, no, I'm saying if it is a completely skewed tree, then the in-order, depending on what type of skew it is, if it is a left skew, I mean, if left is nothing, that means it is going to be increasing, correct?
Yeah.
The in-order will be always sorted.
It is not a binary search tree, right?
Oh, my bad, my bad. Yeah, good point, good point. Yeah. Sorry. Then there is no way.
Yeah. But could be the tree which I've constructed, that could be a BST, right? I mean, that's a they have written binary tree is a parent, right? BST and all are children of it. So the
No.
tree that we get
Binary
out of,
tree, we cannot change the order. Once we change the order, then there is no tree left, right? Whatever they have given us, we'll have to build on top of that only.
yeah, yeah, makes sense.
So we cannot create a BST out of this. In fact, it is not possible. It may not be possible.
Yeah. Yep, that's good.
Yeah.
Thank you.
Yep.
Yeah. So anyone wants to share the code?
So I think you can go with this one.
So what I did is like, this is just a base case. I mean, if either of your array is empty, then return none. I mean, sorry, if both the arrays are empty, then return none in that case. This is instantiated the object tree node in root. Now, from the pre-order, I'm picking the first element and making it as a root. Root.val equal to 3 it will be. Now, for that particular element, I'm checking in the in order what is the index of it, which I was talking earlier. So it will give you the index of that particular element in your in order. Now, depending on that index, I'll divide it into left and right. So up to 3, I mean, this 9 will be your left, and after 3, that is 15 to 27 will be your right. And we have got in order left and in order right. Depending on their length, we are getting pre-order left and pre-order right. And after that, simply I'm calling the function root dot left is equal to pre-order left, in order left, and root dot right is pre-order right and in order right, and just return the root at last. This is the index that I mean, IDX will give you, which will separate left into right, this in order array into two parts, and recursively it will keep on doing that.
So you will just use that index, IDX, whatever it is, as
Yeah,
is in for the left, but you are incrementing only for the right, correct?
exactly.
You don't have to increment in both places.
No.
Okay.
Incrementation, I didn't get it.
So he actually is using that IDX, right, on line. Oh, don't remove, change that. Okay,
Oh,
line.
sorry. Okay, no, I was
That's
separating
okay.
to make it more specific.
No issue. Yeah, so on line 17, if you see, he's using the same index because it's a left. He's trying to actually
Yes.
find out the left in what you say, the limit of that in order. But for right, actually, he's adding one and then finding it.
I think it is left inclusive and right inclusive, right? I was actually thinking like that. That the last index won't be included as such. I'm guessing that.
Yeah, that IDX, that 3 won't be considered here in left. And here also
Yeah,
after 3 it will be considered from 4.
yeah,
Yeah.
got it.
Okay.
The Python slice operation.
Yeah.
Yeah. And then
What is the complexity of the code?
complexity, each time you are dividing the array into two halves, right? I mean, so let's say if log n such levels, if it is a balance, then the worst case level, best case will be log n, and if it is worst, then the level will be n. So n into n square in worst case, and best case would be n log n, right? Because
I think
if
so.
you,
Yeah, makes sense.
it's the
It
equation will
depends
be like t of n will be equal to this will be, let's say in worst case what happens, one node on one side and other node you get t of n minus 1. So this will be like if you solve this will be o of n square, but in best case what it will be, I mean t2 into t of n by 2, so which will give you log n log n, I mean
that
from here log n you will get n such elements are there, so
Shashank, T of
yeah,
n equal to 1 plus T of n minus 1 is O of n, right?
yeah, o of n, that you will get o of n from there for every element we are doing, right?
Yeah, it depends upon then the index, how the line 15 implementation, right?
Yeah, so index, yeah, exactly.
So I'm guessing it would be O of n itself if the index is O of 1.
No, index, I think it uses linear search internally. Like,
Okay, then yeah,
yeah,
okay, then it would be O
n
of n
square.
square of O of log n log n, depending upon that.
Yeah,
You
yeah.
miss.
Because what Santosh was using, I think some map, no, they're also order of n, right?
Yeah.
Yeah.
Yeah, so
No, no,
same
no,
thing
no,
it
no.
might be.
That would be hash map. It can be hash map, right?
Yeah, but he's
And
like
then the
mapping no every element to its index. So he's going through the array at least once. So order of n for
yeah,
constructing that map.
yeah, and the after that construction is, yeah, I mean, it will be like 2t of n by 2 plus O of 1 itself, right?
O of n, yeah, that
Yeah.
was.
Yeah, O of n plus O of n.
No, so he's doing it in order of n.
Yeah.
No, for accessing, it's going to be O of 1.
Overall,
No,
what
no,
it
that
will
is
be.
overall also it should be O of n itself, because if you see that, I mean, when you have written that equation, 2t of n by 2 plus,
Okay.
right? That plus would be O of 1, right? If you are just
Yeah.
passing the indexes, it will be O of 1 itself. And hash map access would be, I mean, if you are taking it as O of 1, it would be, finally it would be 2t of n by 2 plus O of 1. If you are using that hash map or and passing just that indexes instead of creating new arrays.
Well, see, initially when you constructed the map, it is going to be O of n. That is correct.
Yeah.
Okay. So when you are trying to access it in any of that recursive call, it is going to be just O of 1. But still, in an average case, when you are actually constructing the whole tree, it is going to be n log n. Right. So even if you have anything, it's always going to be
No,
big O
no,
n
N,
log n, right?
n
okay.
log n for base
No, no,
if
no,
it
no,
is a
no. How?
balanced tree, right?
Yeah, yeah.
No, no, no. Even if it is, even if it is not balanced, I would say it is O of n itself. Because if you write that equation, if you are just reusing that array itself, it will become t of n minus 1 plus 1 itself, right? In the
Yeah,
few
if it
case
is a
No,
also,
skewed.
when you
yeah,
are using an array, okay, so whenever you are using it, it's just going to access one element at a time, right?
yeah.
Yeah.
So then that is just going to be O of 1 when you are actually iterating through the whole thing.
Yeah, so that is why I'm saying, oh, it would be the overall complexity would be O of n. O of n for
Okay.
constructing the map and O of n for constructing the tree.
O of n for constructing the thing, it is going to be n log n, right?
No, 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 no. Why would it be n log n?
Log n levels are there, right?
But you are constructing for every node, right? So why
Yeah,
would
for
height
every,
come into picture?
No, let's say first time you constructed 3 and its root are let's say 5 and 6. Next time another route when you will take, you have to go one level down, right? So each
No,
time your
1 minute.
level is increasing to open.
Shashank, can you write that equation? I will tell you. P of n equal to.
Just let me clear this one.
So it will be O of n for constructing the whole tree. That is what you're trying to say.
Yeah.
The whole tree, just the whole tree, right?
Yeah, just the whole tree.
It's only O of n.
Yeah. T of A.
Yeah. Okay, sorry. It makes sense. You are trying to say it's not going to be n log n, it's going to be O of n. Yeah, that is correct. But if it is a skewed tree, then in that case, it is still going to be O of n.
Yeah, even if it is skewed or balanced, it will be O of n itself.
Yeah, makes sense. I'm sorry. Well, why I took that log n, I don't know. Okay. Yeah, makes sense.
No, but each time you are going through this pre-order, depending on that, you are selecting it this, and then it will create one more level. So next time when you take this 20, it will go to this level. So it has to cross this much level, right? So in
What he's
worst case,
trying to say, we are always going to construct a node, right? Every time, one node at a time, right? Whatever the way you do it, is it not?
Shashank, can you write that equation? That would be better. T of n equal to T of A plus T of n minus A plus O of 1. O of 1.
T of?
Some x. T of x plus n minus T of n minus x.
Okay, this is T of n minus x.
Plus O of n. O of 1, sorry.
Constant one, yeah. For constructing, right?
Yeah. Accessing that hash map.
Yeah.
And passing that indexes itself. Yeah. So what would be the time complexity for this equation?
So you have to substitute for what you say. I mean, without solving, how to say like.
No, so, this could be a linear one, right?
Yeah.
You are always adding O of 1 itself.
Okay.
At every level, you are adding one element itself. So by the time x becomes 0, you will add only x once. And by the time n minus x becomes 0, you are adding only one n minus x once itself.
Yeah, but whenever the tree comes in, we just think about the levels. Actually, it should not be that way. Here you are actually constructing the whole tree, but you have to go through each and every node, so it's going to be just O of n. Makes sense.
Okay.
Yeah. Okay. So yeah, you are going through that. Okay, that's good. But actually, the way I did, I did not use this. Okay, I'll also quickly share mine.
Sure.
But I used a not really good way. It was something like I used global variable. Yeah.
But yours is very optimized, like order of n only it's taking.
Yours is also the same.
But recursively it's trying to.
You are also the same. I don't think so. There is something different, but only the way we were discussing was not so proper. Yeah. That is what Uday corrected us. Yeah, that's okay. Right, Uday?
Yeah.
Okay, so this is the build tree. Yeah, this is the preorder. This is the Inorder. And I'm using this index of this preorder PIDX, and this is the class variable. It's like global for me. So that's the only thing I don't like it. But the way Rajendra was saying, I could have used it in the recursive parameter itself, recursive functions parameter. I didn't do that. So here actually I'm creating this map for this Inorder one. And this is my helper function where I pass preorder, Inorder, and then I give these bounds. Right. So I come in here and actually I check if L is greater than R, the bounds are actually incorrect, then I return null. Or else I find my midpoint or whatever that pivot is using the map. Okay, and getting the value from my preorder. Here P vector is preorder. Okay, and then I get that value, and then I create a node out of it. And if my left and are same, in that case, I just return the node, or else I go in the tree recursively, right? Then at that time, I just say L and M minus 1 and M plus 1 and R for right.
Just a sec for interrupting. Like these two will be the recursive equations found, right? I mean, those two helper functions. So the T of n, if it is the entire, then L to M minus 1, and other will be M plus 1 to R, right? Which is equal to T of x plus T of n minus x, what you were saying.
Right.
Yeah.
So, okay, the result of that one will be linear.
No. It depends upon what you are adding apart from that equation. So the line 18 to 21 would be that O of something, right?
Okay.
So that will become that that can be n, that can be O of 1. It depends upon that.
Yeah. So here it is O of 1 because MP is a map. It's an unordered map. Okay. And then I just access one element out of it. So that this is O of 1, and that is the only one which has impact, right? So,
Constant, yeah.
right.
Okay.
So he's saying this is important.
Yeah.
Makes sense. Okay, but the way I did was, I don't think this really is a good way of doing it. Having a
I have a
global index.
solution where I combine this thing, which like I've given the range. The main thing is like I am just incrementing this, which you have taken index, P index. I like here only I took it globally and just incrementing it. And when I call the like find index, I created a function which is find index from the Inorder. I just gave that a range from this start and end.
Okay, yeah, you can share it, yeah.
Sure.
You share it because that would be more like.
Can you see my screen?
Yeah, it's coming. Its font is too small.
Okay.
Yeah, please increase it, yeah. Yeah.
So, so I am just calling this build tree function with Inorder, Preorder, and start and index. And this is just like if it is greater than, start is greater than end. It's a exit condition. So here I am taking a pre-index globally and I am making a root node. And I'm just incrementing whenever I'll be going the next level. So here is like I am finding an index. I am giving this root value and I am giving my start and end. So start and end would be like 0 to end. And for example, if I have to find 3, the 3, it's just finding the index from the Inorder of the 3 value and returning me the index from the Inorder. And then I'm calling recursively, which is start, and because my left would be the index minus 1, so my start to index minus 1, like it would be this, and end would be here, like my right would be this, index plus 1 to end.
Right.
So I'm just calling it recursively this function and just taking this incrementing by preorder.
So you're explicitly doing that find index?
Yes, I'm doing that. Like you have used map.
Yeah.
I'm finding it.
Yeah, so your space complexity is of 1 in this case, correct?
Yeah. Yes, it
Makes
is
sense.
reduced. And the time complexity would be same because I am, it's like we are not going to same node again because it's dividing over here. Sometimes it like seems
Yes.
like so
it will be reduced every time. Okay.
Yeah, it will be reduced and it will be order of n.
So that function, the find index, will be order of n, right? O of n for
Yeah,
finding every time
because it is searching in that,
linear space, right? Yeah.
but it's searching in that particular range, start and
Mhm.
end.
Mhm.
So it is not the whole in order. It would be like, yeah, for
Yeah, to some
one
extent,
time
yeah.
it would be going. So yeah, it is in order of n.
Mhm.
Correct.
Yeah,
Yeah.
that's good. Yeah, no problem.
Okay.
Yeah, thank
But
you. Yeah.
people have actually I mean, I was trying to understand the same similar solution. People have tried to do without map as well, like Rajendra was saying, right? Like a BST approach. The people are trying to do without the map itself. I
Mhm.
mean, without searching in the in order, people are trying to do.
Okay. How is that?
But how we come to know without searching that this is the index of the value which we are searching from the in order?
Anyway, I have sent a link. If people are curious, you can open that link. I mean, I didn't understand it, but that seems to uh, work if, from what people have said. I
Wow,
have
it's
sent it in the
such a
chat.
clean solution, and it's very concise also. Yeah. Okay. Okay, but that pre-order, I don't know. Yeah. You wanna have a look at it? Can you bring that on the screen, Shashank, if possible?
Yeah, let me share that.
Yeah. That seems very interesting. The JavaScript one, at least. I didn't go through the Python because I won't understand that.
Yeah, he even explained why JavaScript that uh, he's not passing any bounds as such in the JavaScript, so that it would work for every case.
Maybe it's something to do with specific JavaScript.
Yeah, yeah.
Okay. Okay. So this guy, you have a built tree as a function pre-order in order, and then you have this stop. Yeah, okay. It's not a stop, and then so how is he reducing that for left and right?
So, I mean, I didn't understand it completely, but the guy, he is trying to pass that particular root node into the left subtree as a stop point. He is then identifying that there won't be any left after this indexes, after this index. Yeah, I mean, from that point, he is returning null and going on till that point and trying to construct the right subtree. So if you see that root dot left equal to build dot root val, he's passing that corresponding root into that root as the stop point for constructing uh, for stopping the construction at some point.
Yeah, that might be a good one, but I'm trying to relate in C++ perspective or the Java perspective. So yeah, maybe I'm not able to come up. Okay, I can see some other variant of it. Yeah, but it's really
So
cool.
yeah, so basically the main condition is here itself. That if condition is the main trick.
Hmm.
So how is he doing? How he is mapping that root dot val to that particular in order at that index, and he is finding that now he shouldn't construct that any tree below.
But if he is satisfying that if loop, he might be doing it recursive many times, right?
Yeah.
Yeah, calling the.
Uh,
No, but he's
there
not
might be
calling.
some redundant calls in that.
No, no, no,
But
no.
he's not calling anywhere, right?
The build
Only.
itself is the same thing, right? Because the build is a recursive call.
Yeah, yeah, yeah. Inside. Yeah.
Somewhere he has to take care of it. Yeah. Okay.
But build is a variable to which he is associating the function, right?
Yeah.
Yeah, that function.
So, so basically, he is passing that corresponding route at every point of the left subtree, so that he will identify when to stop constructing the left subtree, and right subtree is he is not doing anything like that. If you want Java one, I can send you. People have done try to imitate that same thing.
Okay. Okay, that will be a good one. Yeah, so Python actually, yeah, you guys might be knowing about how to. Okay, you have sent the Python, yeah, Java one also. So it is a DFS approach.
So root dot right build stop. So what that stop will contain, like.
So he, whenever he is constructing that left and right subtree, for the left
Okay.
subtree, he is passing that corresponding,
Value.
yeah, whatever is at the root, the corresponding constructed node, he is passing to the left subtree, and for the right, he is passing whatever he's got from the previous call.
Oh.
And that if condition is actually telling him whether he has to construct that particular node or not.
Okay. Yeah.
So in the Java version, they are using two indexes, one for that preorder, one for Inorder.
Here also
There.
he is using that both P and I, right?
Mm-hmm. Okay, makes sense. Then it is slightly, yeah, because when you find an in-order index, then you keep on incrementing it. Wow, that's really cool, actually. Yeah.
Extra. I mean, it's a very nice one.
Yeah, absolutely.
No.
It's the most optimized one. Yeah.
Yeah.
I wonder why they haven't included that in the solution. They haven't included, right, in the solution.
Yeah, yeah, yeah. Yeah, this guy is writing also most of the solutions, like, I mean, good ones.
Who is this person?
It's Stephen Watchman, something like that.
Oh.
And it has been reviewed by
Did someone
173
write?
people. Yeah, cool.
Did someone write the iterative approach?
No, I didn't. Yeah. Do you have it?
I saw one solution discussion that was. I was looking for solution. Got one iterative discussion.
Okay.
Okay, share the link. This was kind of using a stack and for the left side and trying to construct. I think it's even this one is pretty good faster.
Okay, so the iterative will always have a stack, correct? Yeah.
Yeah, yeah.
Yeah.
So he's using stack until he tries to construct the left subtree, and when he's going to try to construct the right side, then he's going to pop the elements, and that way he's somehow using that stack.
Mhm. Yeah, I think, yeah, so this is good, stack one, yeah. But Uday, actually, it makes sense, right? We don't have to worry about what you say, the bounds of an in-order when you are constructing the tree, right? So if we just go the pre-order way, and if we keep on moving that pre-order's index, should work.
No, no, no. I mean, he he's doing some clever logic of comparing that in order and that pre-order element. Uh, 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 just incrementing pre-order won't do. You need to track that element, how it is, where it is occurring in the in order. Then only you can identify whether you can construct or not.
Yeah, so those two base conditions what he is using, right? The one
Yeah,
which he looks for whether the pre-order, it is at the very end of that. Okay, so it
yeah,
means that it's a complete. It doesn't have to do anything more, right? And or
yeah.
the else he's going to look for if that value whatever is coming as a parameter is at the current index of the in order. Okay,
Hmm.
so if it is there, then only is going to increment that in order index, or else he will say that okay, I'm still in that in order tree in that bounds,
Yeah.
right? So that is actually he's trying to minimize that, and that is really a good way of doing it, because in our case also, in my case also, even if I'm splitting the tree into left and right subtree using that in order bounds, I'm not using it actually, only for the base condition, right, to see if they have crossed each other. So he is almost doing the same thing here also.
Yeah,
Yeah, but
similar condition, but he's uh, without without using the map, he is trying to you he. I mean, in our solutions, we are actually passing that indexes as well, right? The range we are passing proper range. If that I mean the root value is occurring at index, we are passing 0 to index minus 1, index plus 1 to whatever is at end. We are passing proper indexes, but this guy is actually just incrementing pre-order index and in-order index itself and trying to find whether I can construct right subtree or left subtree or not.
yeah, but even if we are passing, we are actually not completely utilizing that information. We are using to very small extent. So I think that is the trick actually what he's trying to exploit over here.
Okay.
Yeah, maybe I'm not sure. Yes, we'll have to think over it. But it's a very clever way of implementing, I would say. Very neatly done. Okay, cool. So sorry, sir. Yeah, you were in that stack. I'm sorry.
I mean, it's good to discuss. Yeah, so our last one is like we are moving stones until consecutive. So we are an infinite number line is given, and the position of that stone is given by stones of I, and call a stone an endpoint if it has the smallest or largest position. Each time we pick an endpoint, and we are supposed to move it to the unoccupied position so that it is no longer an endpoint stone. In particular, if the stones are at stay 1 to 5, we cannot move the endpoint stone at position 5, since moving it to any position 0 and 3 will keep that stone as an endpoint stone. The game ends, then you cannot make any more moves. That is, the stones will be at the consecutive positions. And so we are supposed to reduce, what is it, maximum and minimum number of moves that one could make, and return the answer as a length of 2 array. So in the first example, they are trying to move 4 to 8. So 7, 8, 9 becomes a consecutive position. So in one move, they are able to make it consecutive. And this is the minimum. And for maximum, if we move 9 to 5 and 4 to 6, then again 4, 5, 6 will be in a consecutive way. And same here, 3 they are moving it to 8. If they move 3 to 8 and 10 to 7, then 4, 5, 6 and 7, 8, 9, 7, 8, 9, 7, 8, they will be in a consecutive one. And this for the other, I mean, what do you say? The other one, maximum one. And notice we cannot move 10 to 2 to finish the game because that would be an illegal move. Yeah. 10 to 2 can't be moved. Okay. And here already they are in consecutive, so we can't move anything. Yeah.
Okay, so if you look at that example too, and in the first one, like when you move only two, when you finish the game within two moves,
Okay.
right? So when he's saying that you can move from 3 to 8 and 10 to 7. Can't we do it 3 to 7 and 10 to 8? That should work also, right?
3 to 7 you will move, right?
Yeah, if I move 3 to 7 and 10 to 8, will that not work?
But orientation is you're disturbing, right? I mean that here 3 was earlier and 10 was later, right?
So question is, are we making it increasing or decreasing? Like how we are making it?
Consecutive. I mean, try to make stones at the consecutive
It
positions.
can be
I mean,
in decreasing consecutive.
no, it can be anything. It's not like increasing or decreasing. It should be
So
consecutive.
is that we can change just 10 to 2 and it will be consecutive 6, 5, 4, 3, 2.
No, but order you are disturbing. No,
How
10,
order?
10 to 2 means first 10 will come, then 6, right?
Oh, okay.
So, but here 10 was supposed to come after 6, right? Okay, I'll have seen one. I'll show you this one. These are diagrammatic. They have represented. This is the example like 1 to 99 and 100, right?
Okay.
So these are the empty positions that you have to fill. So they're trying to move one, but here again order they're taking, right? So it's like
Okay, so in this case, what is trying to do is 1, 2, 1 is moving after 2, right?
yeah,
In the first step. And then he's again moving 2 to make it after 1. So he could have done it like this also. Instead of 1 moving after 2, he could have moved 1 before 99. That
yeah,
also
that
would be fine, right?
yeah, one before 99, right?
Yeah. And then 2
Yeah.
again before that 1. So that could be done in 2 steps, right?
But so won't the order be changed? Like yes, initially I started 1 and then 2. This same order has to be fulfilled, right?
Oh, okay, I got your point. How this is the order we have to maintain. But
Yeah.
okay, so now in this case also when he's doing it, he's still flipping it, right? So here he moves 1 after 2, right? So now it is 2 and 1.
But those are
Okay.
transition states, not
Yeah,
the end.
that's fine because why he's assuming that whatever the holes are, they are of even or odd length, whatever they are, right? So
Okay.
it might all come to some point that some of them are not odd or some of them are not even. So at that time the order will be flipped. No,
Yeah. Good. I mean,
yeah, what you're saying it makes sense because I was also trying to understand that, and that is what actually confused me to some extent why all these things are. You know, so
yeah.
really the order
Yeah.
matters or not, I'm not sure.
Let's take this
In
one.
the,
Yes. Go
actually, in
ahead.
the question, mention that the order has to be same in the end, right?
At the end. Mhm.
Yeah, I mean, not at that. Like at any point of time, the only thing the game ends is when we can't make any moves. So I don't think order matters really.
Okay, okay. Then my bad. Sorry. Yeah. So yeah, Shashank, that should be fine. Whatever the way we move, it is okay. It means, right? As long as we bring all of them together.
It should be consecutive. That's it.
Yeah, it should be, yeah, consecutive.
Yeah.
Then only it will end, right? Because we can't move at the time.
Yeah, exactly. Yeah, that's.
Uh,
But then what you were telling, that was also correct only.
it should be, yeah. That is what I think.
But
Because
you didn't
you,
mention. Why didn't they mention that? They could have mentioned here, right? What telling?
they are not mentioning about order. I think that is what I even really pointed out, right?
No,
So
you were reversing here. No, that case they didn't mention here. Like 3 to 7 and other 1 to 8.
I think that should also work. If you put 3 to 7 and then you move 10 to 8, it's you have a gap there, right? In 8 and 7, they both are empty.
Yeah, yeah.
So whatever the way you put it, it's fine. It's only two
Yeah.
moves. They are counting moves. So for us, it's
Yeah.
okay. But
For you,
maybe the way why they are doing that way, programmatically, it is easier to do it. That might be the way. You know,
would be.
there's something why they are doing it always like that. You know, they go from one to the extreme one, and then the other one to the other
Next.
extreme. Yeah, yeah.
Actually, I think 3 to 7, 10 to 8 doesn't work because one of the rules is the endpoint stone, when you move it, it has to become no longer the endpoint. That's one of the conditions in the problem.
So if you move that, then it's still not an endpoint, right? Either of it, because if you move from 3 to 7, it is still inside.
Yeah, but when you move from 10 to 8, then you're moving 10 is endpoint and 8 is
Oh, yeah.
it's gonna be another endpoint.
Oh, got your point. Yeah. Makes sense. Because yeah, 10 will still be an endpoint if it moves to it. Yep, that's right.
So it shouldn't be the end point again and again. Same thing.
Yeah, we have to make it as inside. We have to push that inside. Yeah.
So in your
Yeah.
case also 3 will be outside only, right? Whatever 10 will be at 8 and 3 will be at 7.
No, when you move from 10 to 8, then 10 is still an endpoint. 8 is also an endpoint. Yeah, Annie. Great. Yeah, thank you. Thanks for bringing that. Yeah, that's very important. So that is one of the rules we have to follow.
Yeah.
Good. Okay. So, as yeah, great. Go ahead.
Remember, we solved. Actually, we solved the first version of the same problem in our. I think we solved it the first version in which we have only three elements. Uh, in this one, we can have any number, but in that first version, we have only three numbers, where we try to do the same thing. We try to move them to the closest. I mean, maybe we can apply the same thing on the whole list.
Oh, so you are trying to say that there is one more problem which is almost the same, but
Yeah,
Yeah, I mean, we solved it in the SD session only, where we have only three elements in the list every time. That's the first version of moving stones and consecutive. Here's the second.
okay. Oh, this is the second one. Okay. We have
In
already
that
done
we
that.
have, like the example one, we have only three elements. Then what we try to do is, if we have a gap between the two elements, then we put that the outer element in between them, so that it becomes the range becomes minimum, or else we move the middle element outside, something like that. So maybe we can do the same thing, but we have many elements in the list.
Yeah. So this is an advanced version of the previous problem. Yeah.
Yeah, exactly. Yeah.
I think it should maybe I'm just thinking depend on the size of the gap, like the hole. If you have two holes, then you want to finish the game fast, then you will try to move to the smaller hole. But if you want to go slow, maybe you go to the larger hole.
Okay.
Larger hole, like what do you mean?
Like the length of the hole, right? Like you can think of it as you have some holes or gaps between the number.
Okay.
And then if the length of this hole um, is large, then you want to finish the game fast, then you will fill that hole first.
Mm, the
So
beginning one, right?
so
The
you
end.
you are saying that if the length of the hole is greater, you won't
Yes.
fill that one first, right? You'll go for the one which is smaller.
Yeah. Like if you want to go slow, right? Then I think you will fill the bigger hole first. If you want to go fast, finish the game fast, you fill the smaller hole.
So slower hole, like you are telling this one to fill first. This is the gap
Yes.
between them.
Well, okay, so that one you only have one hole, then I think basically like what you guys said, if you just have one hole, you want to go fast, then you just uh like if you want to fill it up slowly, then you do like the illustration, you do one at a time. But if you want to fill it up fast, you go all the way to the end.
Yeah.
Okay. Yeah.
Okay.
No. I think lower hole is fine, but for the maximum, I think you need to just fill the holes at the ends first, and you try to reduce the holes length by, reduce the holes by one or two, something like that. Yeah, see, if you see that second one, move the leftmost. Yeah, so you are trying to decrease that whole number of holes by one. So you are not going by the whole length.
But in this illustration, the hole is the same, so you're saying it doesn't matter which hole you will.
No. Actually, I thought the greater one would be uh, try to reduce the holes by one. So
Right.
you only try to remove the end holes.
So our first for minimum, our first choice will be this one, right?
So, but Uday will have to do it for both, right? The slow as well as the fast.
Oh yeah.
So either of it
Yeah.
will have to do it both ways. Yeah, Shashank, what?
Okay, maybe we should go through the solution. Yeah.
Yeah. Shashank, what is this? What you're trying to explain?
No, I was saying like what I was saying.
If there are multiple holes, you are explaining that.
Yeah, I was saying if multiple holes are there, since there is only one gap, right? If I put this, fill this hole first, then the chances of this being consecutive will be more compared to putting that element in the larger hole. Does that make sense?
Yeah.
Or
Yeah,
See,
because
so
we have to pick up either 1 or 200, right? That part we don't have a choice. We have to pick the endpoint. The only question is where does that go? Where does say we pick up the 1? Where does the 1 go? If we have many options, then we pick based on something.
okay.
Okay, but okay. So, what is this problem? In what category this problem falls?
Yeah, this is like, I mean,
Is it a DP problem?
no, it's not a DP. Though we have choices here, but
I think greedy maybe. I'm not
yeah,
sure.
kind
no,
of.
it's a puzzle.
Okay. Okay. So greedy or puzzle. Okay.
I mean, look somewhat too greedy because trying to fill it.
Hmm.
Yeah, so, yeah, person here.
Yeah, but it's not so straightforward to come up with an
Exactly.
implementation.
Understanding the question itself is
Yeah, I understood it just now, so it's
uh,
difficult. Yeah. So, but they have given very small. Yeah, so this is the one. What it's a sorting one. So
yeah,
usually you do a sorting. That is what they say, and then you find those two, minimum and maximum. No, it's the same, minimum and both are minimum.
yeah, and then they are going from I and j both they are running as long as the j is less than n. Aj minus ai plus 1. This is the gap, right? Aj minus ai plus 1.
Is it a gap? Uh,
Gap
so
between two.
okay, but okay, so you have a loop which runs from J. Uh, J is one what is running loop, and you just have an I, an
Okay.
element I there also. But you are actually incrementing the I in this while loop. You're trying to compare whatever the elements of this difference between the AI and AJ. So you're trying to iteratively walk through each and every element of this sorted one. So when you have sorted, you know that both the consecutive ones are going to be, yeah, they're the first ones always. So that is the reason you are trying to find some difference, and you are trying to see if the difference is greater than n. So right now the n is nothing but the size of the array.
Yeah.
So if it is greater, then you know that you can compress it, and therefore you are incrementing the I.
I
So
and then there are
yeah.
yeah.
But initially, when I and j both are 0, this doesn't make sense at all. So it's not going to do anything. It'll just go through that already store, whatever that value is. It'll just find the value of that j and I, where the already stored is still the value of 1. Okay, and then you come here down. Also, the first if loop is not going to be, it's not going to meet that, so it will go in the else part, and then it will say whatever that L low, which is n. You're trying to say what is the minimum, and already store is 1, so n minus 1 will be the low, right? So you have decreased your size of that array by 1, means
One.
the low one, yeah. So low will be n minus 1, and then you go through that whole loop again. uh, Frankly, I didn't understand that. Yeah.
So what is the overall intuition here? Like, I mean, if we have larger gaps, then I mean, it still looks like a bit confusing one.
I didn't get that. Yeah.
Yeah,
So
like
I just following through the code, and then yeah. They say
see
it's a
that.
sliding window or something, right? So
Yeah,
someone
looks like
comes.
yeah, they're saying like that.
Anyone solved this, or who can I do a walkthrough? Gone through this problem? Okay. I don't think so. So we should start. Do you have anything want to talk about the walkthrough of this code?
Me, no, I mean, I couldn't get much out of it. Like, I was trying to follow this, but intuition, I haven't got. Like, it's
Yeah.
just like going through the code, it will be, but getting the overall intuition,
Yeah, at
not.
least something, because I think Henny has some idea, right? He was,
Yeah, yeah, yeah. Let's see.
or Uday.
What was like the same thing the code was, but
Okay, I think both are not active now.
yeah. Oh,
Okay.
so I mean, same thing like what they
No,
were doing. As,
I didn't solve it.
Yeah, me too, actually. But I was just thinking, we can go through this code, at least if we understand it to some extent, because.
Can we find the intuition for like small, only one single hole first?
Okay.
What would be the slow one? What would be the fast one?
For single hole, single hole means. Wait, let me open the diagram.
No, I think he. Yeah.
Yeah, go ahead.
So Leon, I think Leon wanted to go through the examples, right?
Yeah.
No, I just say, if we can find the intuition for one single hole, then like someone say, right, just reduce one hole at a time and see, if it work or if it not work.
Single hole, this like this you are talking.
No, just reduce one, hole at a time. So let's say we reduce the left one first, right? If we reduce the left one, probably one will be max to 100, right? We have 1 and 100. And then the second hole.
Okay. So you are saying that we need to find like the gaps between 1 and 100, that is the holes, and then try to find a hole which has only one element in between, yeah, of size 1. And then you try to move one of that endpoint inside that, So you are sure that this is not going to be an endpoint, it is going to be somewhere inside. So this will be the right place for that guy to go in. Yeah. And therefore, they are actually having a while loop for each and every consecutive sorted element. They're trying to find holes. And they see if the hole sizes are more than one, they try to fit as many endpoints as possible. If it's the lower one, if it's the faster one. And in that way, you keep on doing it till you don't. Oh, you'll have to do for both in the same while loop, right? Yeah.
But here they're filling for the leftmost point.
Yeah. So what Leon was saying, in this case, when you have 100 and 102, so you know that you have 101, which is a hole. So you can easily move 1 to 101, right? Because it is not the endpoint. So it's not going to be endpoint for sure because it has two elements which are side to each other, right?
Yeah.
So that's the safest bet. And then keep on moving in this area again to find how many holes are there, and correspondingly try to see if it is between two numbers, two elements. So you are sure that whenever you are moving to these holes, they are actually not going to be end up as an endpoints. And in that, when you are traversing the whole array, you are also trying to calculate the number of moves, because the number of holes are equal to the number of moves, right?
Yeah.
So that way, if you can go ahead,
So
sorry.
here, if initially my endpoint is 10, I mean 200, then it should remain 200 in the last also, is it?
That's not necessary, right? So, what do you mean by 200 in this
Like
case?
in the first year, 200 is the endpoint, right?
Uh-huh.
So the final solution that I'll obtain there also should 200 be the endpoint, or it could be anything there.
No, it can be anywhere as long as you actually bring all of them together. Like you have how many elements? 1, 2, 3, 4, 5. So you bring all the 5 elements together. So you are done. So wherever your elements lie, that's not important. But the only thing is, whenever you are moving one element, it has to not be an endpoint. That's the only constraint. So whatever the way you do it, it's okay. So you can move 200 to in the first place also, where like 100 and 102, 101 position, you can move 200 there too, because 200 won't be an endpoint when it is moving in. But when it is moving in, it exposing 105 as an endpoint, then that's fine. Because your move should, when you are moving your element, you should not place that element as an endpoint. That's the only thing you have to take care of.
Okay. Like I can't move one beyond 200, right?
Yeah, because then that will be an endpoint, right? So whenever you are moving, you should place that element in such a way that you are not actually moving, making that as an endpoint. That only carry you have to take. So if you do that, then so the while loop actually what they have written it very concisely and yeah, very
Short.
clever way, and therefore it's very difficult to interpret. Yeah. But if you look at it overall, yeah, I think this might be slightly okay. So overall, that is what it comes to. But I didn't understand the two ways we have to make moves, right? One is the slow way and one is a faster way.
Fast way, yeah.
Yeah. So I actually, if we do it this way, what Henny and Leon was saying, like if we move one to as first as 102, 101, and then keep on moving 100 to after 102, and then again 1 to after at 103 or something, you know. So that will end up as being fast or slow, I don't know. But
That,
we,
yeah, that,
yeah, we just keep on doing it. I think, okay, what we might have to do, you know, we might have to keep on doing it and just find out which are the maximum moves and which are the minimum moves. You know, so ultimately it will evolve to that way. You know, like whenever we do moves, okay.
yeah.
Oh, yeah, but how do we know that it is ended?
It's like
Yeah,
slide.
because you will have to find an uh, at the end of the game, you know, to find which how many moves you have done
Yeah.
every time. Yeah, that's that's very tricky.
Yeah, a bit confusing. It's like, yeah.
Yeah. So you can at least do it in one way. Somehow you can stop the game and then you can find out whatever the value is. But whether it is the maximum moves or minimum moves, I
That
don't
is,
know. Yeah,
yeah.
that actually doesn't come out from this code also what they have written here.
Intuit, yeah. Very cleverly they have implemented this.
Mhm.
Yeah, let's keep this problem for Sunday. What is your, if anyone?
Yeah. Okay.
No.
Maybe if we get to get this solution, let's
Yeah,
share it on the Discord, one of
sure,
us.
sure. And then we can discuss. Yeah.
Yeah, no problem.
Okay.
Yeah, Leon, you want to add anything in this?
No, I don't know.
Yeah,
I
but
have
yeah,
to
that's a
think.
good point what you brought in, you know. At least we are able to come to some conclusion. Yeah. No issues. Yeah. So,
There is one more. Can you go to the